Hi, we're back with the Advent Calendar project and hopefully we're going to finish this in this video. So just a couple of tasks remaining. Now first of all, quite a few people suggested gluing some of these dividers in place between each of the houses. So I think that's what I'm going to do to correct for my error on the actual PCB, and what that will do is provide a lot more contrast for the houses that are being illuminated by the LEDs inside this area here. And then the other task that I want to do is to 3D print a roof structure to sit on the top of this to finish it all off, and also 3D print something to sit on top of the numbers. So what I've done is I've imported the overall outline of these houses into FreeCAD and then basically just extruded a roof shape. So let's take a look at that. So here we are in FreeCAD, and basically using the DXF files from Adobe Illustrator, we're able to just import that directly into here and then take the roof line and extrude it out 2mm. So basically what we end up with is 2mm of material thickness all the way along the roof line here, and then I've extruded it 82mm deep so that it covers the depth of the houses. And this has been split into 4 sections, as you can see, so that we can print this on the 3D printer, because the 3D printers only have a limited size bed. So there's going to be 4 pieces that sit together, and then this should hopefully just sit on top of the PCBs. So we're going to try printing today on a printer that's recently been sent to me by Banggood, and it appears to be extremely good value if it prints well. So let's take a look at it on the Banggood website. So here it is on the Banggood website, about £152 delivered within the UK, and if you pick the UK warehouse then it actually gets shipped just domestically. Takes about 2 or 3 days from the point where you order it, so really fast delivery. And if it prints well, at £152 I think this is relatively good value for money. So I think a couple of things worth pointing out when I was getting the bed levelled on this. The first thing I noticed is that it seems to use some pretty decent stepper motor drivers, because the motors, first of all, appear to be able to move extremely quickly, way faster than any of the other printers that I've got in the lab. Also, the stepper motor noise is almost non-existent, so the Geetek in particular is very, very noisy, and it's quite distracting if you've got it going on in the background. When I was just playing around with the bed levelling and moving the head around, it did appear to be almost silent, which is really quite nice. The other thing to note is that it does have a 220 volt heater for the bed, which has a couple of advantages. So first of all, this heats up really, really quick. Within about 20 seconds it's up to temperature, whereas on some of the other printers it takes maybe a minute or two. And the other thing is that because it is running from the mains, it's not using the low voltage power supply to heat the bed. And what happens on some of the other printers that I've got is they've got fan-cooled power supplies, and then you hear that fan cycling quite regularly when you've got the bed heater on, and that can be quite distracting. And if you're trying to work in the same room, or even if you have it in your bedroom for example, that can be quite distracting. We've also got dual Z-axis motors, which reduces the tendency for the Z-axis to slope on one side. There are other ways to fix this, but the dual motors works quite nicely. Now I do have this on the Creality 10S Pro, but the problem is when you de-energize the motors and leave it to stand, what can happen is if it's not already perfectly aligned, over time it can start to sag, and then when you turn it back on, it's misaligned. And although you can do some of the bed levelling automatically, it never quite works properly. Now what they've done on this one is they've added a belt drive at the top to keep the 2 sides in sync. So basically you get the additional power from having 2 motors, which increases the speed, but also always keeps it in sync. And this is a mod that I want to try and do to that Creality 10S Pro. Now the other thing that I've noticed is that everything appears to be integrated into the print head. So we've actually got the filament feed and motor and everything all in here, which should give us much better prints. The problem that I've had on some of the printers, for example the Geetek one, where the filament feeder is at the top of the printer right next to the spool of filament, is the retraction settings don't work very well. And because there's a little bit of slop in the entire mechanism and from the filament to the head, what you end up with is quite a lot of stringing between parts on the 3D print. So I'm hoping that this one really resolves that issue, which is my main gripe with that Geetek printer. So I've just used Cura to slice the STL files, and let's see how it prints. So here you can see we're heating up, and the bed is heating up extremely rapidly, probably going to get up to temperature just before the extruder. Now that the head's printed up, we can feed the filament into the print head. and we want to push it through a little bit so it comes out the bottom, and we should be ready to print. Right, it's just finished printing. Let's see how easy it is to take off the bed. And that seems to have cracked off quite nicely. So here is the finished print, and overall it looks pretty good. And the printer itself was really quite silent. I did have to keep coming in the room to check it hadn't finished. On the other machines you can normally hear it going, but this one very, very quiet indeed. Now we do have a couple of flaws in the print. So there's a bit of a rough edge along here and along here as well, but I think this is more down to the slicer than it is to the printer. It was depositing filament in all weird places rather than following the contour of the roofline. I'm not as familiar with Cura as I am with Creality Slicer, and while this was printing I did actually print on the Ender 3 the other parts using Creality Slicer, and it tends to follow the shape of the roofline a lot better. There are still some points where it bridges across to print something else, but I don't know, I always get really good results with Creality Slicer and really bad results with Cura Slicer, so I think some of these flaws in the print, which we can scrape off, are more down to the slicer than it is anything to do with the printer. Now whilst those were printing, I did use some 2-part epoxy to glue the dividers into place, and that seems to have worked quite nicely. I also added a DC jack and the button onto the end piece here, so what we can do now is check that these parts of the roof actually fit on top. So hopefully this all goes quite smoothly. So we've got a bit for each part, as we saw before, and that fits quite nicely onto there. And again, a good fit on that. And yeah, we've got that fitting all the way across quite nicely. That looks quite sweet actually, I'm quite happy with that. Now the advantage of having a bunch of 3D printers at my disposal is that even while it was printing all of that, I was able to print something else. So we used some sparkly silver PLA material to make something to cover the top of these numbers. So this is fairly straightforward, just a little design to make it look like there's a bit of twinkly snow hanging from the top of these numbers. Unfortunately, because the PCB is so long, 500mm, I did have to segment this into a couple of sections, and also I think this PLA material might be a little bit transparent, so I may have to back this with something, or maybe paint it with some black acrylic paint or something, because yeah, you can see the light shines through. So here's the overall effect, and I'm pretty happy with how this project's turned out. If I was to revisit this, and I may well do next year, there are a few things that I would like to have improved upon. I did give myself a fair amount of time for this project, but as always it gets eaten up by other things. So, for example, the import process from Adobe Illustrator into Altium was not straightforward. It interprets the DXFs as a bunch of primitives, but then I had to individually create every single polygon on there. I think from that process I had to group them. There is a command then to create polygons from it, but I can't do anything automatic because the graphics were quite complicated. So that ended up taking many evenings to get all of that imported. But my wife did all of the graphics in Adobe Illustrator. I think all of that looks really, really nice. And overall the project looks good. I mean, the 3D printed parts fitted perfectly on top. There's just a little bit of a gap under a couple of these parts where you can see a little bit of light bleeding through. But overall I think the effect looks really nice. So I will put the files on my website, but I think I'd be tempted to wait until next year. I'll try and get it done earlier next year, so that if you were planning to build this project, we can do it a little bit cheaper, because I didn't end up panelizing all of those internal dividers, so the cost went up because of that. But the numbers and the houses and everything I think are as optimized as they need to be. Anyway, I hope you enjoyed the project. If you've got any thoughts or comments, don't forget to leave them in the comments section down below. Big thank you to the PCB sponsor, JLC PCB, who provided all of the boards for this project. And a big thank you also to my Patreon supporters. So until next time, thanks for watching.